Action, madam. Good morning.
Good morning,
Good
sir.
morning, sir.
Yeah, good morning. Now back here with a lesson in last topic. We are going to conclude with our IoT syllabus today. Uh, Now we'll start with the commercialization of buildings that we have seen in a last class. That the videos which we have seen on the Delta electronics as well as on the Google, how they are going to make a commercialized buildings and how they will take a contract of that particular buildings, especially in energy conservations, that is the utilization of an energy and green buildings, and how they are utilizing the security, and then how they are allocating a space for meetings whatever is there in a building, and how even a parking everything they have taken care of that particular thing which we have seen in videos, and how the CEO of the company they have told how they are going to give a solutions in what way, and with the practically they have shown the equipments also, and they have made we have even seen the building infrastructures also. Now coming to the syllabus, what is there in this particular case study? This is the last case study which we are going to study. And entire the commercial building process has been divided into two phases. That is the phase one and the phase two. And what actually the in a phase one they will do, and what actually in a phase two they will do according to the syllabus, we will see, and we'll compare that with the Delta Electronics as well as in a Google. What we have seen and what we are studying is one and the same, or not like that. We can go with this. I think you are hearing my voice, right? You are hearing my voice. Any
Yes,
problem is
sir.
there?
Yes, sir.
Yeah, no. Now I'll share the PPT. We'll start with the particular topic. Just, yeah. I'll go with, yeah. Now, coming to this commercial building automations, in that first we'll give go with an introduction. That is a building automation system. BAS is a computer. What actually you mean the commercial building automation means? The BAS is a computerized intelligent system that controls and measures lightning, and underline these things. What are you going to concentrate? Lightning, climate is also important, security, and other mechanical and electrical systems in a building. Especially in a commercial buildings, this plays a very much important role. When AC should be on, at what temperature always the AC should be there, based on number of people who are coming in, how the AC should be regulated automatically, and how a lightning should be there automatically, based on a numbers and based on temperature and humidity, how you can maintain room climate. That is also an important which we have seen in Delta. The director he used to tell like this: we have to give a working environment or a working climate where everyone are pleased to work in that particular climate. That is also an important thing. So based on this, we are going to study now. The purpose of a BAS is typically to reduce energy and maintenance costs. This underline this. Why the commercial building, a civil structure has to come and ask us, we need a automation, a software or an electronics company, they will come and ask why we need a means automation building, especially to reduce the energy and as well as a maintenance cost. If that things has been reduced, for example, assume a commercial building is getting around some 3 to 4 lakhs of a current bill, and you will apply some IoT technologies, or you will apply some computerized automations to that, and you will tell you will apply this particular thing, the savings will be there. For example, I can say you will reduce around 40% of your current bill. So even if you tell like that, means it comes around some 2 lakhs, around like that. When it is of 3 lakhs like that, means saving 2 lakh, 2.4 like that. So almost all saving of nearly 60 to 70,000 per month will be there. So then if you tell around some these many lakhs, for example, I can sell 5 lakhs as an installing of this particular project, even though coming in a period of a time they can gain that particular amount. Why? Because you can tell in electricity itself you are losing this much of an amount. So that like that. So reduce the energy and maintenance costs, as well as to increase the control, comfort, reliability, and ease of use for maintenance staff and tenants. So controlling should also become a easy, means increase the control over the each and every part of a building, and comfort. This is damn very much important today's sorry, any office or a commercial building, means it goes within a comfort first. How much comfort if you are providing that much way, means they will pay for that particular thing. And reliability means how reliable this particular space for me, like that. Some example use cases you can see here in this particular thing: control of heating, cooling, and ventilation based on time of a day, outside temperature and occupancy. Example, morning warm up. This is another one very much important thing which you can see: control of heating as well as cooling, both they need, and ventilation based. For example, I can say today it's very cold. Sitting here in a cold environment and all, we can't work like that. Definitely, heating equipment should be there, and heating should be maintained. Means heating machine should be on in your particular. Means location or in a place, then automatically temperature should be controlled. For this, how we are going to do this? Based on outside temperature, how you can be cool like that. Then automatic control of air handlers to optimize mix of outside air in ventilation based on, for example, inside temperature, pressure, and time of a day. So based on inside temperature and based on the pressure, how much is there, and outside how much is there. So how an ventilation can be controlled. Supervisor control and monitoring to allow maintenance staff to quickly detect problems and perform adjustments. Outsourcing of monitoring and operations to a remote operations center. You can take data collection to provide a statistics and facilitate efficiency improvements. Alarms for high carbon monoxide and carbon dioxide levels. Yeah, even though you can have that alarm levels if carbon monoxide and carbon dioxide levels are more in that particular company. So how you can make your air quality good, to removing this particular carbon monoxide and carbon footprints. Coming to, sorry, yeah, coming to the next thing, individual metering per apartment to give a sensitive to save energy in multi-tenant buildings, means how a metering should be there always. So how much we are utilizing now the power, and how we can reduce power. For that, definitely a metering system should be there for each and every usage of the energy. And intrusion and fire detection, if somebody are coming inside the unknown person and all, or how the security system you are keeping without the interruption of the humans, and fire detection systems, how you are going to make activate the automatic fire detection system, building access control. So all these things. A bus is normally distributed by nature to allow every subsystem to continue operation in case of failure in another system. How a bus system should be there, means building automation system. If one particular system has been failed, it shouldn't be like that. Entire the automation should be failed. For example, I can say like this: the controlling of an AC or the temperature and humidity in a building, and it shouldn't relate with an lightning. So lightning control shouldn't relate it. If one thing will stop, other things should work at least like that. So always it should be in a distributed thing. So that means that the automated lightning system should be a separate one, and solar what you are utilizing, that should be a separate one, and how you are utilizing the smart gardening and all in a building, that should be in a separate one, and how you are controlling entire humidity and temperature, that should be in another one particular thing. So all these things should be taken care individually. Now sensors. So what are sensors? These devices that measure, such as the thermometers, motion sensors, and air pressure sensors, which for that we are going to use other sensors. Actuators, what are that? Means controllable devices such as power switches, means relay models, which we are going to use, thermostats, and valves, sinusoidal valves, wherever it is needed. We can use that. Even automated restrooms and all we can make. Means utilization of water also you can do. Then programmable logic controls. This is very much important. See, programmable, doing a project of an IoT is one side, and programmable logic controls is different. What is this programmable logic controls? For example, I can say like this: how your entire programming modules can be controlled from one particular point. That is very much important. I can say like this. For example, you will do a model-wise project. For example, lightning one, and room temperature, and humidity maintenance, gardening, and all. For entire, you have did an individual programming and all. So one main program should be there, from where you are going to call all the sub modules and work accordingly. And you will write a code like that, programmable logic controls, when this should work and when this particular module should work, how continuity of working should be there and all. So programmable logic controls that can handle multiple inputs and outputs in real time and perform regulating functions. For example, a server which monitors and automatically adjusts the parameters of the system. So like it should act like a server there, and it should manipulate all that particular sub modules there, while allowing an operator to observe and perform supervisory control. That will be done by PLC. One or a more network buses you can use if you want. Always the controlling point will do from one point. So how you are going to do from one particular point? You will connect other boards or other devices to this, and you may write a code, or within a one particular board only you can make a distribution. It depends on your project how you are going to implement a building automation. Now, case study phase one, commercial building automation today. Now we'll go with the phase one of an building automations and background. First, we are going to study that. Company A wants to improve the energy efficiency in their buildings and become a green building partner 2013 certified, which requires lowering their energy consumption by at least 25%. After discussions with a building automation company B, they have come to understand that this is a very good investment that will quickly justify itself in terms of reduced energy cost. As I told you that, assume that now per month around 5 lakhs, the current bill which you are paying, if we reduce 25% to 30% of that particular bill, so investment is not a cost there, and you can give a good proposal even to make a building automations. They agree on a 5-step plan that starts with collecting data from the building, followed by analysis, adjustments, and connecting the systems in the building to a local server, and finally connecting the building to a remote operations center. In a first step, what the 5-step plans they have did first. Always when somebody will call you and they will tell ABC, means a company called and they told that they want to reduce the current bill of that particular building. Then suddenly we will go to the market, bring sensors, bring a board, and not like that. So how will you do a project? First, you study the building with the current equipments. That is very much important. Studying with current equipments plays a very much important role. That is presently how a meter is running, how much power utilization is there, in which particular block more power is utilizing, or in which particular floor more power is utilizing, and what for the purpose this particular power is utilizing, where actually power leakage is more. You should analyze this particular thing, where the analyze and adjustments and connecting the systems in building to a local server. So we want to meter all the particular things. Individual meters will be there. You can ask me like this, sir. Entire our campus is having an BESCOM meters will be there, and if you study the current bill, it's enough. No, it's not like that. So each and every block and each and every floor wise, may I need to study that where actually the leakage of power is there and all. So if BMS Institute of Technology and Management will call me and they will tell that you optimize our particular energy system and reduce the current bill. First, what we have to do, we have to go with a black voice. We'll collect the current bills of that particular buildings individually, and we have to monitor that based on that particular bills. Why this much of the power utilization is going on? They can now start with collecting data from existing systems. In some cases, this requires new meters to be installed 100%. Maybe floor wise, I want to study, maybe or rooms wise, I want to study in which particular locality the energy is utilization is more. Everything from water usage to heat and electricity consumption is logged continuously, as well as performance of the ventilation and room temperatures also. How much AC utilization they are doing, how much the geysers they are using for an hot water and all. So anytime geyser will be on, so what will be the power utilization? So to monitor all these things, we need a separate meters and we should watch that particularly. This is the first phase always we have to do. Coming to the next, one of the most central features of the improved system is the new web-based e-report. It provides information about current energy consumption and other key parameters from the building. Now, what I will do, entire study meters, everything I have adapted and I have made connected to a local server there on a web-based, and I will keep on watching that particular thing. For example, in which particular floor of which block the power utilization is there. What about a night times? Somebody oftenly lifts out switching on a bulbs and all. Either in daytime also with sufficient lights also they are utilizing a power. For all these particular things, these meters will help me, and ongoing meter readings we can see there. So it provides information about current energy consumption and other key parameters. This information is used to make both short-term decisions as well as a long-term planning. So once if you get all these particular details, then you can decide that now what we have to do. How our project should be. Either our project should be on a short-term basis, or either our project should be on a long-term basis. How a long-term solution can we give, or a short-term solution can we give? The next phase of a project consists of connecting the systems in the buildings and analyzing the dynamics to be able to perform intelligent control. Now, if we apply an intelligent control on this, how a dynamic changes, or how it will tolerate, means how it will work. This both improves the performance as well as reduces the maintenance cost. Now trial basis will start one by one. One floor will start, and we'll see in that particular floor we'll adapt some motion sensors and They means LDRs will adapt, sensors will adapt based on like that. First, for example, lightning and temperature and humidity. Based on that, the lightning we are going to operate and we'll see, and we'll compare with the previous metering of that with present metering of that particular floor energy. And if it is reduces, yes, it's working out, and we'll see the performance improvements is there and how the reducing of a maintenance cost will be done in that particular floor. So as a final step, the final step to completion involves setting up a web-based supervisor control and data acquisition. That is SCADA we are going to implement. This is one of the software which will support the building automations. It's already there. So system for remote monitoring of the building systems. Through the web portal, the users can access information from the buildings in a concurrent manner. So whichever, whatever information you want from a building, you can access from this scan. Now, coming to the next one, technical overview. Now, for this, what a technical requirement will be there. We have studied, we have did everything we have done. Sorry. Now you can see this particular thing, how connectivity will be there and all. A temperature boiler is there, and water, and here a power is there, and HVAC is there, means existing systems. And you can see that based on a temperature, this is a PLC. Sorry, based on a temperature sensor, that is which has been connected with a Z wave connectivity. This is one type on a Wi-Fi like things, the Z wave for a short region of a connectivity. We are going to use this particular Z wave, and you can transfer almost all more data here. That is very much important. You can, if you want, you can Google it, Z wave, and it's a competent to a Wi-Fi. So here you are going to get to the PLC, and that is you can say your board. In our words, yeah, if you want to understand, ನಮಗ್ ಗೊತ್ತಾಗ್ಬೇಕಂದ್ರೆ ಒಂದು ರಾಸ್ಬೆರಿ ಪೈಗೋ ಇಲ್ಲ ಏನಕ್ಕಾದ್ರೂ and the Arduino board like that we are going to take. So there we will do a coding. What we are going to do based on a temperature, how these particular things should work. That is, what should be a boiler, means how we should maintain a boiler based on a temperature. Whether boiler should on or not. Water, how a water solid and all valve should be opened or not. How a power should be maintained. ACs and all should be maintained like that. And you can see the further this PLC board which has been connected with a modem. I can say like this, it's a gateway and a hotspot, especially a hotspot. Usually in our terms, we are going to connect with an hotspot, or you can use any physical connectivity modem only you can use, not other things with an Ethernet. So through modem, you can connect to the internet. That is, I can say any hotspot that 3G they're given today. It's a 4G. It's working on. From there, you can transfer the data to the cloud. How you are going to transfer the data to the cloud? How your PLC control you want to do? SCADA is an already built-in software. How means it's a frame means ERP software which will be there, and you can manage entire building with that. And then data analysis means how you can do analysis based on that for an improvements and all. So this our OPC server will be there. So with this particular thing, you can manage the entire building. Now, each building is equipped with a set of meters and sensors to measure the temperature, water consumption, and power consumption, as well as one or more PLCs. There is no limited on a PLCs. You can use, depends on your project. You can use how many devices you want, means how many boards you want that many use. As in a figure, the PLC perform real-time monitoring and control of the devices in the building. Everyone, we also know that. We have did almost all 27 projects, and all 27 projects, the online monitoring, real-time monitoring we have did with our boards. So they also feature a user interface to configuration and calibration of the regulators, curves, and time delays. It's possible to remotely configure the PLCs from the operation centers using the PLC control system, which is connected to the PLC via 3G modem and an internet. Means how I can control that programming and all, how I can control that particular board. I will sit somewhere in a particular my server system, and I will regulate that. Do this work, do the you have to code this, and you have to work like this and all. Yes, even you can do with a Raspberry Pi, and you can direct and you can give the instructions. The next coming thing is the OLE for process control. That OPC server provides access to data, alarms, and statistics from the PLCs. And when a valve is requested from a user, and request is sent from the user's OPC client to the OPC server, containing on a OPC tag that identifies which PLC to contact, and which valve to ask for. So this is very much important. What your OPC will tell you that how you are going to connect to that, means which board you have to connect, and which model you have to connect, and through that model which valve you are going to, or which part you are going to connect, and how you are controlling that. That things we will come to know. And then coming to SCADA, this SCADA system is used for operational monitoring of the buildings and provides information from all the relevant building systems. This, if you want, you can Google it and you can get a software ERP about this particular SCADA, which is already a built-in one. It uses the open and standardized OPC protocol, which enables integration with the devices from many different vendors. The maintenance and operations staff can connect to the system using a web browser with a username and a password. So, giving a username and a password, like a cloud, I can say like this. ThinkSpeak is like that. SCADA will also work. So, in SCADA, first we will tell what are our building, and what are the things which we are going to put in our building. For example, lights, how we are controlling the lights, and how we are controlling the AC, and how we are controlling the gardening system, parking, how we are controlling the restrooms, like that. Everything we can integrate, and we can set that. Username and a password to access dynamic flow charts, drawing tools, timers, set points, actual values, historic readings, alarm management, event logs, as well as configuration or notification over a mails. So then a value chain. How a value chain will work in this particular, means how you can develop in a project. Hardware manufacturers and vendors, chip and device manufacturers, which we are going to use sensors, actuators, what sensors we want, and what type of modems we want, what is the network connectivity components we want, and all these things will come here. Then software, what are software we want here, actually development and maintenance of the software, including server software and even a device software. And coming to the system integrator, that is a system and device installation, and integration, configuration, analysis, and flow up, means how we can integrate connectivity between the components, and how we can connect with the different models and all. Finally, the service provider monitoring we can do, finally with SCADA, like that. And we can see the routing of the notifications to appropriate members of the maintenance staff. What messages you have to send, to which staff we have to send the messages and all, how a notifications you can give and all. That is a service provider. Now coming to the phase two, commercial building automation in the future. Now coming to the phase two. Now it's presently we made this building as an automation building and all. In future, how you are going to maintain this? In future, how you are going to evaluate this building automation? That is very much important, which will come in a phase two. Then evaluation of commercial building will come here. Two major factors will derive the evaluation of a building automation. One is information, and another one is legislation. So these two factors will always affect us. Now you can see the figure below. What is a figure here? It is there. You can see the data is there always. Information marketplaces, data aggregates, data analysis, which we will do based on the data and information we are going to generate. Environment awareness, energy prices, social media, apps and services. From that information we will do, and we'll study the behavior of that. Once the behavior we have studied, new demands for that particular information and admissions, device condemnations, regulations is there, and smart grid. So what are the changes you may need in that particular behavior and all? Again, connected to the devices. You are going to connect to devices, big data, cloud, open data, and legislations. So all this, in turn, it will keep on circulating. I want a ABC. Once I got ABC, after ABC, what is there? After ABC, DEF is there. DEF, after DEF, what is there? Like that means, just an example I'm telling you. So if you start any of the product, any of the project, if you do, one cannot do a 100% project or 100% solution through the project, or 100% solution no one can give. Based on the usage, based on the feedback, and based on behavior of your project, and based on that, the modifications is always needed, and new data formations will be there, and you keep on updating that, evaluating that particular process. That is, the access to well packed information will provide the basis needed for the decisions and behavioral changes. Always. This can be electricity prices for where and when energy is used, and will allow for well founded decisions that provide the best results. Market growth will result in economics of scale, standardization, and commodizations, driving down prices and increasing the availability of devices and services. I will tell you one very important thing. So after installing a package and all, IoT automation and all, assume that you have reduced with the 25% of electrical bills. Why? Because you have used the PDR sensors, CLDR sensors, based on a motion, based on a light. You are controlling your entire light systems and all. So through the mobiles and all, central controlling systems is there, where you can switch it on and off even in the night times. Somebody has left out, like that. So definitely will reduce the energy, means electrical bill. Now, the further step I will tell you. Okay, we are reducing, not an issues. Why can't we go with an solar systems? If we almost all more energy is there, and we are dropping out this energy simply, why can't we use this nature energies? What about, why can't we go with a solar panels, which the glass systems what we made and all? Why can't we place a solar panels there, and collect the energy from that solar poles, and later on store in a battery? So why can't you utilize some energy, like, for example, all LED bulbs of corridors, and staircases will connect to that particular solar. Only that line we are connect to the solar panels, and we'll see the next metering of that particular thing. How can we reduce that? Now, what is the cost of that particular solar panels which we have implemented, and for one floor we'll see first what will be the power. Again, assume that more than a 50% or 60% of the electric bill has been reduced, then there is an advantage. Like that, always with this particular data, if this much is there, then why we can't go with other things like that? A few years have passed, and company A has decided to outsource the maintenance of its buildings to a local contractor who provides services to several other customers in the neighborhood. This will save money, since that will enable them to utilize a shared caretaker board. They have decided, assume the company A, after automation and all several years, bill everything has been reduced. Now they can't maintain these automated systems and all. They want to give to other company. So like this, once they will give to other particular company and all, automatically that companies, especially, my intention is here very clear that how you people will be placed in a commercial building automations. For example, when this particular question arises, you must always think, sir, I did a MCA and now how I will go with a commercial building automations and how I will sit there. What is the relation between me and an civil terms? So always these questions will arise. But in future, this is important. This will save money since that will enable the to utilize a shared caretaker pool and a contractor. Almost all companies will become a contractor in a later stages. So even your Google, your Delta, they will come under this particular category. And once the building has been set up and everything it has been done, so the maintenance of that entire building based on the power utilization of that entire campus or industry, and greenery, everything, they will going to give to other companies. The other company will be company B will be your company, and in your company you will be a employee, and you will be placed definitely in that particular sense. So in this way, commercial building automations will come in our next thing. When I did the course, now I'm doing a course in on based on IoT in Coursera. There they have shown me one video. What happens once the 5G will come in a full fledged? How the IoT will grow? Whatever now IoT is there, you believe or not, it will grow in another 10 times of it. Imagine what is a 5G. They have told very clearly what is present internet which we are using now. We'll use more than 10 times of that. Uh, each and every device we want to speak with our device. We want to make our device uh, through our smartphones. We want to talk to our devices. So when these terms will comes, I'm leaving my house now. I want to make my car temperature to keep in so and so temperature, and I will tell my car in another 5 minutes or 2 minutes you switch on so and so audio, and when I'll come near to you, if I press a button in my mobile, start the car. Then open door, just click in a mobile, sit there, and I'll tell, right, auto parkings, almost all, everything. In coming next, another, you know that we are already in a 4G, and when it comes to the 5G, definitely, these type of projects will become more. In another 10 years, only IoT based projects, solar machine learning, and AI, means artificial intelligence. It will rule the world. It will rule even your IT industry also. With this, I'll conclude my entire session, what I have told based on this. And in a coming class, we discuss on questions. So, one of the important class I can say on Wednesday. Wednesday. I will discuss on a questions. What type of questions will come for exam, and how you should write an answer. That and all I will discuss. So almost all everyone, you tell your friends also, those who are not attended now, let them attend on that particular two classes. I need almost all two classes. So based on that, definitely everyone will pass if you study what I will tell, what type of questions I will tell. If you read that, you can make. And almost all my PPTs, whatever is there, it's like a notes. Don't worry about that. Whatever is there in my PPTs, if that much you will write, uh, almost all it's correct. Why? Because I've taken almost all each and every important points and I've put in my PPT for all the 5 units. And important questions of this particular unit also I will tell on a Wednesday class. Now I'll stop here. Now this ends your entire 5 units. Yeah, any doubt is there here? You can ask me. Any doubt is there? Any doubt is there? Any doubt is there in a commercial buildings, phase one and a phase two? Phase one, we are implementing presently with the present building. Phase two, we are evaluating for a future changes. With the analysis of data, information and behavior of that particular project. Based on that, we are going to do the changes in a phase two. Any doubt is there? Hey, Matadrapa. Any doubt?
No, sir.
What others
No,
are
sir.
doing? I think no one are listening.
No, sir.
No. ಏನೋ ಆದಿತ್ಯ ಪಾಠ ಕೇಳಿಸ್ಕೊಳ್ಳಿಲ್ವಾ?
ಕೇಳಿಸ್ಕೊಂಡೆ ಸರ್.
ಇದು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಕಂಡ್ರು. ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ 2 ಕ್ಲಾಸಸ್ ಆಬ್ಸೆಂಟ್ ಆಗ್ತೀರಾ. ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಎಲ್ಲಾರನ್ನೂ ಬರಕ್ಕೆ ಹೇಳಿ. ಅಲ್ಲಿ ನಾನು ಹೇಳ್ತೀನಿ ಯಾವ್ಯಾವ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ, ಯಾವ್ಯಾವ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್, ಹೆಂಗ್ ಓದ್ಬೇಕು, ಹೆಂಗ್ ಆನ್ಸರ್ ಬರೀಬೇಕು ಅಂತ. ಆಲ್ಮೋಸ್ಟ್ ಆಲ್ ಅದೇ ಬರುತ್ತೆ ಅಂತ ಅದನ್ನೇ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟಿರ. ಆಮೇಲೆ ಡೋಂಟ್ ಥಿಂಕ್ ಲೈಕ್ ದಾಟ್. Just in my experience of teaching this for a fourth time or a fifth time, almost all okay. Salpa, it's worth to read that particular portions, and based on a module I will tell you, means 1 2 3 units or all 5 units I'll tell you. So especially Wednesday and Thursday almost all attend agi. Okay na? Okay na?
Okay, sir.
Yes, sir.
Sorry. Okay. Now I'll take attendance. What is the date today? 21. Aditya,
Yes, sir.
and I will tell you the attendance also. You can make a note of that. Out of 46 classes, Aditya is 40. Ajay? Ajay? Ilwa avuna? Tell him 37. Amit?
Yes, sir.
41. Antima? Antima? 39. Apurva? Apurva? 41. Ashwini?
Yes, sir.
38. Out of 46, I am telling. Bindu?
Yes, sir.
36. Divyesh? 14. Gaurish?
Yes, sir.
33. Gautami?
Present, sir.
38. Gunashekar?
Present, sir.
43. Harini? 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 Next, Surya?
Present, sir.
40. Naina?
Present, sir.
43. Nazma?
Present, sir.
41. Nidhi?
Present, sir.
36. Pradeep? Pradeep? 42. Preeti?
Present, sir.
45. Rajesh?
When we will be getting up?
Rajesh? Tell him 28. Sahadev? Sahadev? Tell him 32. Saket?
Present, sir.
28. Santosh? Santosh? 31. Seema?
Yes, sir.
41. Sinchana? Sinchana? Sinchana 45. Purti
Present, sir.
36. Shashank
Present, sir.
45. Varsha 44. Yashaswini 44. Amrita 37. Anucha
Amrita present, sir.
Amrita ಬಂದಿದ್ಯಾ 38. Anusha
Present, sir.
43. Apurva K
Present, sir.
44. Sai Siddharth, tell him 31. Chetana K Chetana 42. Kavya 30. Madhushri
Present, sir.
39. Manish 43. Sarfaraj
Present, sir.
43. Murugesha
Present, sir.
45. Mani 33. Paresh
Present, sir.
38. Pooja
Present, sir.
45. Prashant
Present, sir.
43. Pratibha
Present, sir.
44. Pratik 27. Sadhana 25. Shashank
Present, sir.
35. Shraddha
Present, sir.
40. Sridhar
Present, sir.
44.
Present, sir.
44. Tanuj
Present, sir.
Tejaswini
Sir, present, sir. Tanuj.
ಹಾಕಿದಿನ
ನಂದು ಹೇಳಿ ಸರ್ ಎಷ್ಟು ಅಂತ
43.
Present, sir.
43. Tejaswini 41. Honey
Present, sir.
42. ಆಶೇಷ್ ಕಡಿಮೆ ಇರೋರೇ ಇರಲ್ಲ ಯಾವಾಗ್ಲೂ. ಆಶೇಷ್ 34. ಟೆಲ್ ಹಿಮ್. ವಿದ್ಯಾ
Present, sir.
43. ವಿಶಾಲ್
Present, sir.
44. ಓಕೆ
Sir, roll number 34 present, sir. ಆಗ್ಲೇ mic work ಆಗಿಲ್ಲ.
ರೋಲ್ ನಂಬರ್
34, sir.
ಯಶಸ್ವಿನಿನಾ?
Yes, sir.
53 also, sir.
45 ನಿಂದು.
Okay,
ಯಾರು?
sir.
ಏಯ್ ಸಿದ್ಧಾರ್ಥ, ನೀನ್ ಹೆಂಗೂ ಡಿಟೈನ್ ಬಿಡಲ್ಲ. 32 ಲೆಕ್ಕ ಮಾಡು. 46 32 ಡಿವೈಡೆಡ್ ಬೈ 46 ಎಷ್ಟು ಪರ್ಸೆಂಟ್? ಸಾಯಿ ಸಿದ್ಧಾರ್ಥ್
ಹಾ ಸರ್ ಮಾಡಕತ್ತೀನಿ ಸರ್.
ಎಷ್ಟು ಪರ್ಸೆಂಟ್ ಬಂತು? ಎಷ್ಟೋ
78 ಸರ್.
ಡಿಟೈನ್ಡ್ 85 ಇರಬೇಕು. ಈ ಸಲ ಹೇಳಿದ್ದಾರೆ ಕಂಪಲ್ಸರಿ ಇರಬೇಕು. 69 ಬರುತ್ತೆ ದಡ್ಡ. 32 ಡಿವೈಡೆಡ್ ಬೈ 46 69.5 70%. ಏನ್ ಮಾಡ್ತೀರಾ ನೋಡ್ಕೊಳ್ಳಿ. ಇನ್ ಮಿಕ್ಕಿದ ಕ್ಲಾಸಸ್ ಎಲ್ಲ ಕರೆಕ್ಟಾಗಿ ಅಟೆಂಡ್ ಆಗಿ. ಅಟ್ಲೀಸ್ಟ್ ಟೈಮ್ ಇದೆ, ಜನವರಿ 10ರವರೆಗೂ. ಅರ್ಥ ಆಯ್ತಾ? ಅರ್ಥ ಆಯ್ತೇನೋ?
ಎಸ್ ಸರ್.
ಕಡಿಮೆ ಇರೋರೆಲ್ಲ ಟು ಟೆಲ್ ಯುವರ್ ಫ್ರೆಂಡ್ಸ್ ಆಲ್ಸೋ. ತುಂಬಾ ಕಡಿಮೆ ಇದೆ. ಕಾವ್ಯ ಬಾಯಿ ಏನಾಗಿದೆ ಇವ್ರಿಗೆಲ್ಲ ಗೊತ್ತಿಲ್ಲ ನನಗೆ. ಆಶೀಶು ಅವ್ರದ್ದು ಕಡಿಮೆ ಇದೆ. ಸಾಧನ ತುಂಬಾ ಕಡಿಮೆ ಇದೆ. ಸರಿ, I'll stop recording.